before the break, we took a look at the group by feature, and now we're going to speak about merging different data frames and turning them into a single data. So let's say we have two data frames. Here we have df1 and df2, and if we display them, you can see that the two have the same columns, but they have different indices. So the first one is 0 through 3, and the second one is 4 through 7. And it's pretty obvious these two data frames almost beg us to merge them together. And in this case, it's very simple. We can simply use the concatenate function of Pandas. And you can see that this function, it gets a list with some number of data frames. And then it simply stacks them together row-wise. So it will take the first 4 rows to be from the first data frame, and then the rows of the second data frame. And if we have more data frames, it would put them together. And then we get this nice single data frame with all of the rows together. And as a second example, let's say that we have, again, 2 data frames. Now you can see that the two of them have the same index, both of them with 0 through 3, but they have complementary columns. So the first is A through D, and the second is E and F. And again, they really want to be merged together. And this time we want to do it column-wise instead of row-wise. And we can do that with the same concat function. Just here we need to specify that we want it to be according to the columns. So we say axis equals to 1. And then we have the column concatenation that you see here. OK. And the third example, now you can see that we have 2 data frames. And both of them have an A column, but other than that, they have different columns. And they also don't have the same index, as you can see. Now, if we try to concatenate them, say, by columns, then we get something that doesn't really help us in any way. We just get the columns of the first data frame and then the columns of the second data frame. But because they don't have corresponding indices, you can see that each of them just creates different rows. So the first 4 rows come from the first data frame, and the last 3 rows come from the second data frame. And each of them has its own columns, and we'll have none with the columns of the different data frame. And you can even see that the A column is even duplicated. So now we have 2 columns named A, which is generally not a good idea. This can create ambiguity if we try to access columns by name. So we get this strange-looking data frame that is clearly not something that helps us in any way. But maybe there is a way in which merging these 2 data frames would make sense. As you can see, since both of them have an A column, and within this column, it's also a unique column. So you can say that the A column uniquely identifies rows just as the index itself. And you can also see that they have shared values. You can see that, for example, row number 66 in the second column matches the A2 and also has E2 and F2 values, which is like the row in the first data frame that, again, has A2, B2, C2, D2. So maybe we want to merge these 2 data frames together and use this A column as a way to, as a shared reference point between these 2 data sets. So we want to take records that have a certain A value and to merge them with rows that have the same A value in the second data frame. And it turns out we can do that. There is a function in Pandas that does exactly that. It's called the merge function, which you can give it 2 data frames and specifying a column using the on arguments. And then Pandas will just merge them into a single data frame using the A column that both of these data frames have as some kind of assured reference point. And you can see that it even avoids duplicating this column, and you have the A just once. So you can see you get the A, B, C, and D. So B through D from the first data frame, and B and F through the second data frame, and you get the 3 different rows that have short values. So A0, A1, and A2. Even though they appear in different ordering in the second data frame, it doesn't matter. It knows how to find the correct values. And the one with A3 is dropped because it only appears in the first data frame. And then we get this new data frame. And by the way, the index that it uses is completely a new index. So it has nothing to do with the original index of df1 and not with the index of df2 either. So it just creates a new blank index, like you see here.
And now we lost A3 though, right?
Yeah, and you lost A3, yeah. But the merge function can be more complex if you want, so it can have more intricate kind of functionality. First of all, as to your question, what about A3 that we lose? So if we want not to lose it, we can use, you see the how argument, we now state that we want it to be outer merging. So the default is what is called an inner merging, meaning that we will only get rows that appear in both data frames. But if we also want rows that appear just in one of the data frames, we can use the outer merging. And then you can see that A3 still gives us a valid row. Just in this case, it will only have values from df1, and from df2, because it doesn't appear there, we'll get nan values. And there are even more options. And we can also merge when we have different column names in each of the 2 data frames. So in this case, it was easier because it was called A, the column, in both the first and the second data frames. But sometimes it might be that they have different names, the 2 columns. And then instead, you can just use the left on and the right on to specify which column you want the merging to be according to each of the 2 data frames. So left refers to the first data frame, and right refers to the second data frame. OK, and that's just, again, just a basic functionality. I recommend you to go through the help message of the merge function and see exactly all kinds of parameters and things it can do for you. Questions? OK, let's see a more practical example and see how we can merge the 2 virus databases that we've worked with throughout the course. So we have VipERdb, which we worked with earlier today. And we also have ViralZone, which, again, you can find it in the Moodle. It's also a database of viruses that we worked with. So to remind you, ViralZone, as opposed to VipERdb, which contains structural information, in ViralZone, we have more taxonomy information and genomic information for viruses. So if you remember the ViralZone table, it has this genome column, which actually contains JSON encoded values. So if we want to parse the ViralZone, we first need to decode JSON, and we use it using the JSON load_s function. If you remember load_s, it loads JSON not from a file, but from string. And since we have it as a separate string JSON for each of the rows, we can just use the apply function to apply the JSON load_s function on each of the values and decode it from a simple string representing a JSON. We want the actual underlying data structure, which in this case, I think it's an array containing dictionaries, stuff like that. So then we'll actually get Python types that we can work with. And now after we parse the JSON, we can create a new function that you see we apply again on the genome, that for each genome of some virus record, which, like I said, the genome is a list. So we iterate through the different fragments within this genome, and each fragment, some kind of chromosome of each virus, we can get a size, and then to sum it over and get the overall genome length of each virus. And yeah, and then we do the same trick that we did with VipERdb. So we group by genus. This time we take 3 values. We take the group, which is the highest taxonomy group. Then we take the family and the genus. We group by the 3 values. We then query the genome length and calculate the maximum to get the same kind of analysis that we did with VipERdb to take the maximum within each representative within each genus. And that gives us the maximum genome length within each genus. And then we reset the index because we don't want these 3 values as the index. We just want a regular data frame. And that's what we get here. So you see we get for 352 records of different genera, we get the genome length of each one of them. Okay, so that's again repeating what we saw earlier that we can do using the group by function. And likewise, we do a similar thing with VipERdb, again, very much in the spirit of what we've done earlier today. So within each family genus combination, we take the inner and the outer radius, and we take their maximum, and then reset the index to get this nice data frame that for 71 different genera, we get the representing inner and outer radius. And now that we have these 2 nice data frames of genera, one from ViralZone and the second one from VipERdb, we can merge the 2 of them together using the merge function. So you see we give it the ViralZone dataset and then the VipERdb dataset, and we do the merging on 2 columns together. So we want both the family and the genus to be used as the reference points. And now each record that has the same family and genus within the 2 data frames will be merged together. And as you can see, we get 43 different valid records. And now we have the taxonomic values from ViralZone and the genome length from ViralZone. And we also get the structural data from VipERdb. And we also apply the log10 function to get the log10 of the genome length because it's really spanning many orders of magnitude, and we now want to plot it into a simple graph. And yeah, then we can just use matplotlib to create a figure showing on the x-axis we see the genome length in log10 taken from ViralZone, and then on the y-axis we see the inner radius taken from VipERdb. And you can see the 2 of them together, as expected, having a quite substantial correlation. It's not surprising that the larger the genome, it will need a larger capsid to be packed inside. But again, I think it's a very nice illustration of how easy it can be using Pandas to take 2 different data sets and combine them together and run this analysis that uses more than 1 data source quite easily. And that, by the way, will be very much in the spirit of the kind of things you are going to do today in the lab exercise and the homework exercise. So that will really be the theme of like working with different data sets and combining them together into a shared analysis. And Pandas is really good with allowing that to happen. Questions? Okay. So very last topic before you go to the lab exercise, we're going to speak about the MultiIndex, which is something we already came across today. And if you remember, I told you we're going to speak about it. So now is the time. So we saw that when grouping by multiple columns and then doing some aggregation, we get an index that is not indexed by 1 value, but by a number of values. In this case, two values, because we grouped by both family and genus. So you can see that now each record has, in fact, 2 indices. And that is what is called a multi-index. So that's a data frame in which we have two different indices. Now it behaves very much like any regular data frame. The main thing that is important just to understand is that whenever you want to access a specific row, you just need to specify two values instead of one. So if, for example, we want to get the inner and outer radius of a specific genus, we need to provide both the family and the genus, like you see here, and we just provide it within a tuple. So we give it a tuple with all the values. So the first one will be the family, and the second one will be the genus. And we'll just get the specific values that we asked for. And you can see the result is a series of that specific value. And if we want a specific entry, we need to provide both a specific column and a specific row. So the row, like before, is characterized by a pair of values, and a column is just the name of the column. And that gives a specific entry within the data frame and just gives the number. Now, if we try to access the location of the data frame within within a row that is specified only by the family instead of the family and the genus, then it will give all the genera that are associated with this family. For example, if we give the second family, then you can see we get two genera associated with this family. Okay?
Can you do it by the genus only?
No, because not that I know of. Maybe there is a way to access the genus, but not using this syntax. Because if you use this syntax, if you just give one value and not a tuple of values, then Pandas will assume it refers to the first of the two indices. But yeah, it's actually a good question. I suspect there is a way to do that, but I don't know how to do that. So, but it seems it makes sense. There would be a way. But anyway, what's important to understand is now that you access a row giving just one value, then it's actually under-specified, and you actually get two rows, and the result will be a data frame, which can be surprising, because usually we expect that if we use the lock function, then we get a series typically, but not if it's a multi-index data frame. And really the same goes to multi-index columns. So again, if you remember, we could group, say, by family, and then query some columns, and then do few aggregations together. So we want both the mean and standard deviations. And now we have this multi-column situation in which we have each of the two columns is separated to two sub-columns. So altogether we have 4 different columns, and each column is now specified by 2 values. And things will work pretty much the same way they work for the index. So again, if you want to query a specific column, you will have to access this column through a tuple, giving the 2 names together, and only then you will get the column values. And if you want a specific value, you will have to specify the name of the family, and then what radius, and then what aggregation you want. And these 2 values will have to go together because they specify exactly what column you want. And if instead you give it a specific family and a specific radius, instead of getting a value like in a typical data frame, you will get again a series with the 2 different aggregations. So you ask for the inner radius of this family, and you will get the mean and standard deviation of this inner radius. Okay, and if you just try to access a column by the type of radius that you want, you will get actually a data frame of this specific radius.